Okay, so this video is going through the examples that go along with 10.4. The previous video went through the notes, and this one's going to work through the examples that kind of outline what these ideas are talking about. So, and again, the reason we went through all the notes first is they're all pretty related to each other, and so we kind of need them all at the same time to do all the problems. So in question one, we have, well, question 1 through 5, we have this diagram where you've got a triangle that is inscribed within the circle, and we don't know anything much more about it other than they wrote in that one of the sides was 3.9, one of the sides was 7.3, and then the angle B is 28 degrees. And you can see that it looks as though the center on the circle is the letter N, which means that side from B to C is cutting that circle in half. Or another way to talk about that is that's the circle's diameter. So if we're looking at measure of angle A, or trying to find the measure of angle A, we're going to use the fact that we've got a center of the circle at N. So that center of the circle is at N, which means BC is the diameter. I'm going to be drawing a bit on this thing, so I'll try not to draw too much. I kind of like this highlighter to show the outside. So that circle part is 180 degrees, which means the angle associated or inscribed that's associated with the arc would be a 90 degree. So it's half of 180. So the way we would show that or figure it out, would you say the measure of angle A is half of 180, or half times 180, which is 90 degrees. Another way to think about that would be referencing that specific theorem that said if you have a triangle and you've got the hypotenuse is the diameter, then the angle across from that has to be the 90 degree angle. But I think it's easier to think about that whole arc. The yellow arc is 180, and so the opposite, or the inscribed angle, would be half of it, so it would be 90. And then for measure of angle C, we're going back to a much older idea, which is we've got two measures in the triangle. We've got the 28 they gave us, we've got the 90 we just found, and then when we add in the measure of angle C, those three angles together in any triangle, whether it's inside a circle, outside a circle, doesn't matter, equals 180. So 90 and 128 would be 118. And then if I take 118 away from both sides, I end up with 62 degrees. So angle C ends up being 62. And that's using a much, much older idea that we learned about. And then finally, with the triangle, so we found two of the pieces with the triangle. Now we're looking for BC. So BC, the length of BC, and notice it's not an angle, we're talking about a side measure. We're going to take, since we know what's a right triangle, we're going to do A squared, 3.9, plus B squared, 7.3, equals C squared. So that would be BC, the whole side. So A squared plus B squared is C squared. So we have to do 3.9 squared plus 7.3 squared equals BC squared. And I'm gonna continue that right over here. So what that means is I'm gonna square root both sides to get BC all by itself. And I'm gonna leave this left-hand side alone for the moment. So I'm square rooting BC squared. So that means on the right, when you square root a square, you just end up with BC. On the left, we have to punch that into a calculator. So square root 3.9 squared plus 7.3 squared. So let's go to our calculator. So we'll go square root, so second squared. Then we're going to go 3.9, and we're going to square that. We're going to add, what was it, 7.3, and we're going to square that. So 3.9 and 7.3, we're going to square both those, hit enter, and since they're under the square root, the calculator does all the work for us, and I'm guessing we're going to the nearest tenth. We usually do, I'll verify that, but that would be 8.3. So we're going to hop back to our notes, and it doesn't say what to round to. So we've been going nearest tenth, so let's go 8.3, and these two values are both to the nearest tenth, so it seems reasonable we could do 8.3. So again, we'll do square root 3.9 squared plus, 7.3 squared. Where's my calculator? There it is. So there's our 3.9, there's our 7.3. Squaring both of those, square root over the whole thing, and there's our 8.3 when we round up. Okay, so that is the angle A, angle C, inside BC. We've got all the pieces of that triangle solved. Now the last two questions with this are going to look specifically at arcs. So there's question 4 and question 5. So question 4 is looking at arc AC. That's this little sliver of arc up top. And I'm going to grab let's try the green. I'm going to grab the green. That's that sliver of arc from A to C. So that piece that goes along the circle. Well, the angle is half of the arc. So 28 is half of this arc length, which means when I went from an arc of 180, I cut it in half to get to the angle. So now I'm going the other direction, which means I've got to double that 28. So I'm going to take that 28 and I'm going to double it, make it twice as big. So I'm going to do 28 times 2, and that's going to be a 56-degree arc. Again, the thought there being that angle has to be half of the arc. So the arc's the bigger one, the angle is the smaller one. And we saw that with 180 and 90. So I'll write my little 90 in right there. So my 180 and my 90, same idea with the 56 and the 28. The angle is half the arc, which means the arc is the bigger of the two. And then for AB, that one's kind of a cool one. So AB, let's see what other colors we can grab here. Let's go with the light blue. That's the rest of this. And this one's actually kind of more of a common sense one versus a solving one. But we'll do it both ways. So let's actually solve it. The way you would solve that is you'd say, well, the angle that's inscribed is angle C, and that one goes to A, goes to B. So again, same relationship. If we know that's a 62, and we found that up in question number 2, the arc's the bigger piece, so we're going to double that. So 2 times 62 would be 124 degrees. So that arc would be 124. But I think kind of a cool way to think about it is if you look at the yellow, the green, and the blue, those 3 things make up the whole circle. So those 3 things have to add to 360 degrees. That's what a whole circle is. A whole circle is 360, which means, let's say we didn't know what the blue was, which we started out not knowing what the blue was. You'd say, well, I don't know what the blue is. So that question mark plus the 56 I found, that's the green, plus the 180, that's the yellow. Those have to equal 360. Well, 56 and 180, we can add those together. That would be, what would that be? That would be 236. And then we're going to take 236 and subtract that from 360. So 360 minus 236. Well, 360 minus 236 is 124, which is what we found using the inscribed angle method. But kind of a cool result, and that should be how this works. The different ideas within the circle should all overlap and get you the same set of answers. So those are questions 1 through 5. Questions 6 and 7 are a little bigger pictures and they're standalone. So question 6 is named 2 pairs of congruent angles. So 2 pairs of congruent angles. So what we're going to be looking for are angles that outline the same arc. So I'm just going to start with angle A, and I'm honestly just making a guess right now what to start with. But as I look at angle A, it goes down and hits at B, it goes down and hits at C. So then if we can find some other angle that hits at those same 2 points, they will both outline the same arc. And they're not saying what the arc is or what the angle measure actually is, but only that those 2 would be equal. Well, angle D hits those same 2 end spots. So angle A and angle D both outline the same. So angle A is congruent to angle D. Those both outline the same arc. And that means that they would have to be equal to each other. They would have to have the same degree measure. And then same idea, and I'll knock out my drawing there because I think now it's a little hard to see the picture. Same idea, but now we're going to go with the other side of and actually, you know what, I'll go with the red here. Let's see, how do I get back to there? There we go. So if I look at B, angle B hits at A and hits at D, meaning this arc is the arc that gets that we're talking about. That's the arc that matches with angle B. And then if you look at, well, angle C has the exact same 2 endpoints, which means it has the exact same angle. So then angle B would have to be congruent to angle C. And that's all this one is saying. It's not what those angles are for degrees because we don't have any numbers with this problem, just what are 2 congruent angles. Finally, last, question number 7. Find the value of each variable. And this one is drawing back to that last idea in the notes that said opposite angles in a quadrilateral that's inscribed have to be supplementary. So what that's saying is the 100 and the n, those are across from each other. Those 2 have to add to 180. Well, that means n, if we subtract 100 from both sides, n would have to be 80. And the same relationship is going to hold up with m and 65. Those two are across from each other. They have to add to 180. And if we subtract the 65, what would that give us? 115. So that's just taking that idea that these opposite angles would need to add to be 180 degrees. And that's really it. There's nothing more going on with that one. So this is the set of examples that goes with 10.4. At this point, what we'd like you to do is try the 10.4 practice worksheet and then check your answers and then go on after that to the homework.